Trigonometric substitution. Trigonometric substitution occurs when we replace the variable of integration by a trigonometric function. The most common substitution are x equal a tangent of theta, x equal a sine theta, and x equal a secant of theta. These substitutions are effective in transforming the integral involving square root of a squared minus x squared, or square root of a squared plus x squared, and square root of x squared minus a squared into integral we can evaluate directly since they come from reference right angle. Now, if you look at this chart here, so here we recommend, if you are given an integral of the form that square root of a squared plus x squared, we recommend to use the substitution of x equal a tangent of x. If we have something with square root of a squared minus x squared, we use the substitution for x equal a sine theta. If we're given something with x squared minus a squared, we want to use the substitution for x equal a times x times secant theta. Now, sometimes we can use a regular u substitution to solve for this type of integral, but for the purpose of this lesson, I won't go over the u substitution. Right? So, procedure for a right trigonometric substitution: write down the substitution for x, calculate the differential dx, and specify the selected value of theta for the substitution. The substitution of trigonometric expression and calculate differential into the integrand, and then simplify the result algebraically. Integrate the trigonometric integral. Keep in mind that the restriction on the angle of theta for reversibility. Draw appropriate reference triangle to reverse the substitution into the integration result and convert it back to the original value of x. So we have to restrict the domain of the trigonometric function to have the inverse. So we use x equal a tangent of theta, would require theta is in between negative pi over 2 and pi. For a sine theta, require theta in between negative pi over 2 to pi over 2. And noted that they have the equal sign, so it includes the two endpoints. If we use x equals secant of theta, we will require theta in between 0 and pi over 2 if x over a is greater than 1. We require theta in between pi over 2 to pi if x over a is less than negative 1. So let's take a look at the first problem. We have the integral of 1 over square root of 4 plus x squared. So like I said, we have a plus x squared in this case in the denominator. So we would choose tangent as our substitution. So I go ahead and let x equal a tangent. So that will be 2 tangent of theta. And theta have to be in between negative pi over 2 to pi over 2. Okay, we take the integral we integrate both sides. X equal 2 secant square theta d theta. So let's include our requirement here. Theta is in between negative pi over 2 to pi over 2. Now that we have the differential, we go ahead and calculate what happened when we have 4 plus x squared. Well, 4 plus x squared is 4 plus 2 tangent of theta squared. That is 4 plus 4 tangent square of theta. Factor out of 4, 1 plus tangent square of theta. So now we have 4 secant square of theta. Okay. So note that here we want to have the square root of 4 plus x squared. So square root of 4 plus x squared is equal to square root of 4 secant square theta Now, theta is greater than 0 in between the interval from negative pi over 2 to pi over 2. So this meant the square root give me 2 secant of theta. I go ahead and rewrite my integral as the integral dx is 2 secant theta square d theta divided by 2 secant theta. This simplifies to secant of theta d theta. The integral of secant of theta equal ln of secant theta plus tangent of theta plus c. Now I need to put this back in terms of x. Okay, so I need to draw my reference triangle. So I know that, so I given x equal to tangent of theta with equal to tangent of theta. So tangent of theta is equal x over 2. Okay, so I'll draw the triangle. So then tangent is opposite over adjacent. So then the hypotenuse is 4 plus x squared. I can use this fact to rewrite ln or secant of theta is equal to square root of 4 plus x squared divided by 2, and tangent is x over 2 plus a constant c. So this is our answer. Take a look at the next one. So I have the integral of 16 minus x squared dx. So let's consult with our reference. So now we have the root and we have a squared minus x squared. So we want to use substitution at x equal a sine theta. So we go ahead and let x equal 4 sine theta, and theta is in between negative pi over 2 to pi over 2. So then dx equal 4 cosine theta d theta. 16 minus x squared is equal to 16 minus 16 sine squared of theta, and that equal to 16 cosine squared of theta. Substitute all this into my integral. I have the integral of square root of 16 cosine squared of x times 4 cosine theta dx. And then I will take the square root. I get absolute value of 4 cosine of theta times 4 cosine of theta d theta. And note that here I have an absolute value of 4 cosine theta because theta because I don't know whether the value of cosine is positive or negative. And if theta is in the interval between negative pi over 2 to pi over 2, if theta is in the interval between negative pi over 2 to pi over 2, that would then guarantee that cosine of theta is positive. I then can rewrite this as 16 the integral of cosine squared of theta d theta. I will use the lower power identity in trigonometry to rewrite this as 1 plus cosine 2 theta divided by 2 d theta. So then 16 integral 1/2 d theta plus 16 divided by 2 the integral of cosine of 2 theta d theta. So this is 8. So 8 d theta equal to 8 theta plus 8 times 1/2 sine of 2 theta plus c. Now we want our result is in terms of x, not in terms of theta. Okay, so I know that I can rewrite theta. So this equals 8 theta plus 4 times 2 sine theta times cosine theta plus c. Okay. So let's start with our triangle, and we rewrite this whole thing in terms of x. If x equals 4 sine theta, then sine theta equals x over 4. So here we have square root of 16 minus x squared is theta. So 8 sine inverse of x over 4 plus 8 sine theta is x over 4. And cosine theta is square root of 16 minus x squared over 4 plus c. Simplify this, 8 sine inverse of x over 4 plus x times square root of 16 minus x squared divided by 2 plus c. Take a look at problem C. So again, we have a square root of 9 minus x squared. I'll go ahead and use the substitution for sine again. So I go ahead and let x equal to 3 sine theta. For theta is between negative pi over 2 to pi over 2. So dx equal 3 cosine theta d theta. 9 minus x squared will simplify to 3 cosine squared theta. Okay, so if x equal 3 sine theta would mean x squared is equal to 9 sine squared theta. So let's go ahead and rewrite our integral. Now we have 9 sine squared of theta times 3 cosine theta d theta divided by square root of 9 cosine squared theta. This simplifies to 9 sine squared theta d theta, because in theta is between negative pi over 2 and pi over 2, cosine of theta is positive. I can use the reduced power formula to write this as 9, 1 minus cosine 2 theta divided by 2 d theta. This means I have the integral of 9 over 2 d theta minus 9 over 2 the integral of cosine 2 theta d theta. Okay. So now I have 9 over 2 theta minus 9 over 2 times 1/2 sine 2 theta plus c. So this is 9 over 2 theta minus 1/4 sine 2 theta plus c. So we have to expand this out. 9 over 2 theta minus 1/2 sine theta. Excuse me, this is 9 over 4. And this is 9 over 2 sine theta cosine theta plus c. We will draw the reference triangle and we calculate the value for sine of theta and cosine of theta. Substitute it into our formulas. We have 9 over 2 sine inverse of x over 3 minus x over 2 square root of 9 minus x squared plus c. In the next problem, you can solve this using the u substitution by letting u equal to 1 minus x squared, and you can solve this integral that way. However, I will not go over it in that sense. I will use trig substitution here in this problem. I will go ahead and let x equal to sine theta. So then dx equal cosine theta d theta. X to the third now equal to sine to the third theta. And 1 minus x squared is equal to 1 minus sine squared of theta equal cosine squared theta. So then my integral becomes sine cube of theta times square root of cosine squared theta times cosine theta d theta. This simplifies to the integral of sine cube of theta times cosine squared theta d theta. Well, sine cubed of theta equal to sine squared of theta times sine of theta. And I can rewrite this as 1 minus cosine squared of theta times sine of theta times cosine squared of theta d theta. I've solved this integral using u substitution. Let u equal cosine of theta. Du equal negative sine theta d theta. The integral now becomes u to the 4 minus u squared du, and that is 1 over 5 u to the 5th minus 1 to the 3rd u to the 3rd. Now we need to finish the u substitution. And now we have to do the trig substitution. Okay, so we know x equal to sine theta. So then theta equals sine inverse of x over 1. So x 1 minus x squared is theta. So cosine of theta is now equal to 1/5 square root of 1 minus x squared to the fifth minus 1/3 times square root of 1 minus x squared to the third plus a constant c.